In this lesson, I will explain to you how to make the bell-shaped distribution curve and what columns or what type of data we will use in order to make the bell-shaped distribution. First of all, I will explain the definition of the bell-shaped distribution. The term bell curve is used to describe the mathematical concept called normal distribution. Now, what does it mean, normal distribution? Because when we will make the graph, I will show you that this graph has one or single peak height, and at both ends the data is equally or approximately equally distributed. That is why it is called the normal distribution. A bell curve is another name for the normal distribution curve or the Gaussian distribution. That is why we say sometimes normal distribution, bell curve or bell-shaped curve, or the Gaussian distribution, all have the same meaning. A bell curve is the most common type of distribution for a variable, and due to this fact, it is known as normal distribution. Bell-shaped distribution has single peak and tapers off at either end. Single peak height and tapers off means gradually decrease on both sides. It is approximately symmetric. It is roughly the same on both sides. So I will show you how to make it. This is the data. Suppose we have made these three columns. First belongs to class, and class is from 6 to 10 years. Suppose 6 to 10 years kids are in the first class, 11 to 15 years in the second class, similarly, and so on. So here we can say 26 to 30 years old adults are in the fifth class, and so on. And these are the class boundaries. So how we make the boundaries? This is called the lower class boundary, and this is called the upper class boundary. So in order to make the boundaries, you have to subtract 0.5 from the lower class boundary, and in this case we have 6. So 6 minus 0.5, which will be equal to 0.5 is the lower class boundary, and 10.5 you have to add 0.5 in the upper class boundary. So 10.5 is the upper class boundary. Similarly, you can make the boundaries by subtracting 0.5 to the lower class boundaries and adding 0.5 to the upper class boundaries. And these are the frequencies. Suppose in this class we have 3 children, in this class we have 6, and similarly you can say in this range we have 9 adults, here 6 and 3. Now we are going to make the bell-shaped distribution, so we will use these two columns, class boundaries and frequencies. So you have to select the data first, otherwise you cannot perform any function or you cannot make any graph. So these two columns I have to select, then go to the insert, and in the charts group you will find out suitable graph. So open this arrow, and here I will select this, right? But I am going to show bell-shaped distribution in the form of histogram, and I told you that histogram, see, this is a gap between these among these bars, so you have to remove the gap. How you will remove the gap? Just click on these bars. You can click anywhere, right? On this one, this one, this one, and right click, then you will find format data series at the end. Click on it, then here you will see format data series opens, and gap width, so just make it 0. So simple. So see this one, the last line, bell-shaped distribution has a single peak. So this is the single peak, and tapers off means gradually decreasing on both sides approximately equally, right? It is approximately symmetric. It is roughly the same on both sides. It is not necessary that on both sides the data should be same. In this case the data is same, but I will show you. See, if I make 10 here or I will make 7 here, still it is called the bell-shaped distribution, because data is distributed on both sides of the single peak approximately equal. If we will make a line here, you will see it will show just like a bell. That is why it is called the bell-shaped distribution. So select this histogram or bell-shaped distribution. On the design tab, you can change the color if you want from here, right? And here add chart element, open this, data labels, you can put your data, maybe labels in center. These are the frequencies, and on x-axis you have the boundaries, on y-axis you have the frequencies, but now your frequencies also show in the middle of your bell-shaped distribution. So in this lesson, you have learned how to make the bell-shaped distribution and why it is called bell-shaped distribution or Gaussian distribution or normal distribution, because data is approximately equally distributed on both sides. If still you have any question regarding bell-shaped distribution, you can write down in comment section, and thanks for watching.